So first of all, thanks everybody for coming out today and hopefully sticking with us for a reception afterwards. My name's Tony Brunello. I'm the Executive Director of the Green Technology Leadership Group. Today's panel is largely supported by one of our main sponsors and funders, the Energy Foundation. So they are here in attendance today. Thanks to them so much. The main topic for the conversation today is looking at plug loads, largely in California and the United States. Right now, all the devices that you plug into your wall, whether it's computers or set-top boxes, phones, etc., take up about 15% of the energy use in a typical home. We're looking out to 2030 where that could be at least doubled and happening at a much faster rate than we've seen in the past. At the same time, we're seeing a lot of the devices become more energy efficient. So there has to be new ways, new solutions to address that. What we wanted to do today was pull together what I feel are some of the more exciting companies that are out there that you don't always hear about. We often are wowed by our iPhones or different things that you can immediately purchase on the shelves. What we don't always see that are really important here in California that takes policy efforts at a premium is all of these things within the devices are new opportunities to really improve energy efficiency. So that's what we wanted to do today is do two things. One is to talk about that innovation in some of these exciting companies. And second is to at least frame the other side of the coin that really allows us to build and develop that innovation. And that's right now has been in the standards process with the Commission. So we're going to start with Commissioner Andrew McAllister, who we are very lucky to have here today, who is overseeing a number of proceedings at the Energy Commission. One of them happens to be the Title 20 proceedings, also looking at how to make existing buildings more energy efficient, also leading the IPER process for the Energy Commission, which is guiding state policy and really a lot of the background for the state's energy policies. So with that, I'm going to hand off to Andrew to say a few comments and then before we start off on our panel. So Andrew.
Thanks, Tony. Well, thank you very much, Tony. Very happy to be here and I've been looking forward to having this discussion. I'm going to sort of start with some general comments and then target a few comments. I like to think the CEC is one of these innovative companies that's super flexible and doing all sorts of innovative stuff and bringing lots of venture capital to the state. But but the other speakers will definitely bring that perspective. As Tony said, we have a lot of challenges in the state. We have not an insignificant portion of the nation's energy consumption. We certainly have, I think, the most well-developed vision for how to combat or mitigate the impacts of climate change. I think we're leading in the state and some would argue more broadly than that. I mean, in the nation and possibly more broadly than that, which is a great thing. And if you look at the trends, just with a hard note, take a hard look at the energy consumption trends, plug loads are a big deal, and they're going to be a bigger deal in the future. And they provide us with, lots of innumerable great services, and people want them, and they're buying more of them, and that's a good thing for the economy, for our industry, et cetera. At the same time, they consume a lot of energy, and that is looking like it's going to keep growing. We've had a lot of success in the past with our building standards, Title 24, with our appliance efficiency standards, Title 20. That is very well documented and I think pretty much incontrovertible. At the same time, so that provides a great model for sure. At the same time, I think the evolution of plug loads presents us with some challenges. Increasing diversity in the categories for these devices and also highly specialized devices. So really where we, I think, long-term need to go is grappling with that evolution, figuring out logical ways to break things down and to figure out commonalities that are cross-cutting across all these different categories so that we can focus on those kinds of innovations and not necessarily be developing sort of single solutions for a specific category where we can avoid it. And some of the folks in this room are working very hard on conceptualizing and developing solutions that kind of reflect that idea. So I'm really looking forward to hearing them later in the agenda. And you know, I think there are two general. Well, I'll first just comment on you know, some of the really positive trends that I've seen. In previous lives, I've done some research on portable electronics and batteries and different aspects of this discussion, and it's very clear that portability has stimulated a lot of innovation in the electronic arena, and that's a good thing. And so it's produced all sorts of low-power electronic solutions that one pathway I think that's very promising is to make sure that those innovations get put into non-portable electronics. So, you know, how are we going to innovate across the board? But that's just one example. So we need to look for ways to make that happen within the marketplace. But the other pathway, you know, it's great when the marketplace solves these, you know, has an imperative that's inherent in the market and can solve these problems itself. At the same time, in California, we have long-term goals to reduce carbon intensity in our economy. We have energy efficiency goals that we increasingly need to meet to get to 2050 with a reasonably, you know, serious reduction in carbon. And you know, regulation has to be on the table. So if we know solutions exist and they're not happening in the marketplace, then we need to ask ourselves, okay, well, is there a regulatory solution that's required here? There's large social benefit, often many cost-effective solutions that are out there to the user that are doable with today's technology or somewhat new technology that's coming down the pike. And to the extent that there are market barriers and market failures, those, you know, aren't. They can be documented and they can be assessed, and that's really the Energy Commission's bread and butter to figure out where those opportunities exist and where they're not being solved by the marketplace and where regulation is needed to bring in those energy savings. So I think both of those pathways, the market pathway and the regulatory pathway, really need to work together. We're all Californians. We all have the same long-term goals. I think most Californians recognize the imperative to solve the climate change challenge. And across the board, Californians, when you talk about clean energy and energy efficiency, they are broadly very supportive of these efforts. And so I think we do have a situation where this is entirely possible, where the state policy and the regulatory approaches and the agencies can line up very well with the marketplace and work towards a common goal. You know, if there are voluntary solutions where industry can figure out what to do and do it transparently and in a way that's accountable, then that's terrific. I mean, that's you know, kudos to them, and we want to help that process. Where that doesn't happen, we definitely need to maintain sort of a credible possibility of a regulatory process that harvests those savings. And so, you know, I'm very hopeful that we can increasingly make the process collaborative, open, transparent, at the same time serious, robust, and accountable. We've taken a step towards that in this round of Title 20. I'm not going to talk much about that. It's an open proceeding, and I think really today I wanted to focus on the long term, really fundamental innovation on plug loads and particularly consumer electronics, so that we can think a little bit outside the box, get some new ideas out there, and think about possibilities for the future, for future proceedings and for future other kinds of activities outside of proceedings that broadly, as a community that's interested in energy savings and certainly ambitious in terms of our desire to reach our long-term goals for 2030, 2050, that we can make some of this stuff happen and really go forward with a kind of a positive, optimistic tenor and work through these issues, because I am certain, actually, that they are solvable. We have a robust democracy here in California. You know, we don't always agree about everything, and that's how we make our decisions here. And so this kind of event, I think, to GTLG's credit, really is a fundamental building block for that discussion. And I want to be just very supportive. And certainly the stakeholders that are here today and others that are relevant, certainly my door is as open as I can make it reasonably given my workload. I see some snickers in the Energy Commission staff here. But I definitely try to be open and encourage that feedback about our process and new ideas to come into our office. Without getting into a whole lot of details on all the specific things that the Energy Commission does, we've sponsored a lot of research in a number of areas about plug loads and about, really lots of different technology areas. And CalPlug, our center down in Irvine, Dr. Lee is here today, so feel free to talk to him about what they're doing. But a number of both technology development initiatives, but also all the way through to commercialization. So the PEER program, soon to be called the EPIC program, has funded a lot of groundbreaking research there and really to feed this ecosystem of innovation. Whether or not it makes it into a standard eventually, it's still worth doing and it still helps the marketplace. So, I guess, rather than I do have 4 pages of notes here. Rather than read through them and go through all the details, I think many of you in the room are already familiar with our Title 20 proceeding, and have possibly even submitted comments in that proceeding. But really, I want to keep the focus long term and really figure out, look, how can we do things that help California economically, reduce our energy consumption, and make sure that from a self-interested perspective at the Energy Commission in my shop, that we're doing the right things, that we're doing things that really are necessary, that really are fixing some market barriers and failures, and that places where things are better done in another forum, things that are better done elsewhere actually happen elsewhere. And so we want to encourage that as well. So, with that, I think I will pass it back to Tony. Definitely want to thank you all for coming. I know to different degrees, know the presenters that are coming up, and there's some really great ideas that you'll get to hear about later on, and look forward to sharing about those in the reception afterwards. And thanks again to Tony and GTLG for sponsoring, for putting this together, and for Energy Foundation for sponsoring. So thanks very much.
Great. If we could get the panelists to come up here, if they're so brave, come on up. So we're gonna we're just gonna have everybody give a quick overview of their company, give a little bit about their technology. Many you might have heard of, maybe some you haven't. And then we're gonna go to a question and answer session, followed by hopefully question and answer to all of you guys in the audience. So before we get in again, just to mention again, Sacramento is an interesting place. That's one of the reasons why we're here today. It's quite interesting how you go to Silicon Valley and you're always hearing about the innovations that are happening in California in electronics and in developing new devices. It's an exciting place. We have some of the top engineers, some of the most funding comes into this state. At the same time, often when you come to Sacramento and you talk about consumer electronics, not so positive. Often the message is usually what we hear is a voice of no from the industry, or there's different times where you're not always hearing as much of the progress, which is really a shame. Because at the same time, as I mentioned at the beginning, with a look at almost 30% of home use coming from plug loads, it's a major issue that really hasn't been addressed comprehensively. Individual devices that we're going to learn are getting more efficient. But what's happening really should have more attention from the state. And one of those areas has been a little bit of talking about the standards for Title 20. But today is to talk about all that innovation that we hear in Silicon Valley has major ramifications for energy use in devices. And that is one of the things that is Green Tech Leadership Group that we really wanted to focus on, is to try and bridge what you often see as a major gap of industry players that are moving every day to promote efficiency to link more with the policy people. And we know today many of the legislative folks and staff who we met with today are in the middle of creating bills and moving these processes forward, which are essential to keep our state government working. But again, we don't always let them see the innovation that's happening from the companies. So today what we wanted to highlight was some big ideas that we see from some companies that are truly exciting and really helping move the discussion forward and looking at plug loads and energy efficiency. So with that, I'm going to, first we're going to start with Karen Herder is going to talk a little bit and just have everybody talk a little bit about what they do, their technologies, and then we're going to move to a question and answer session. So Karen, if maybe you can start us off a little bit and talk about who you are as well as some of the work that you've done.
Can you hear me now? Yeah. Okay, hi, I'm Karen Herder, and I'm a researcher in the field of smart electronics and smart grid. I've been doing this type of work for about 15 years now. I worked for many years at LBNL, and I worked at the California Energy Commission for a while. Now I'm helping Tony with some of the technological issues having to do with smart electronics and smart grid. And one of the things we worked on together last year was a report on smart electronics that I think there are copies over here if anyone's interested, where we put together a lot of numbers actually for those of you who are numbers people on where did we start out and where are we now and where are we headed. So in 1980, there were maybe 20 million devices in the United States, and more recently there's more than 350 million of these in just that 30-year span. So if you break those down, a lot of those are actually portable devices, but a good number of them are, for those of you who have the report, you can see there's televisions, there's audio, video, computers, set-top boxes, battery chargers, etc. And all of these together make up about 15% of electricity consumption in the U.S. right now, and of course that's expected to grow. All of that depends on whether or not we do our job here in making these devices more efficient. I'm actually pretty optimistic, call me crazy, but I like to think that we are going to be more efficient, and with folks like the guys up here on the panel who work for companies that know that we can make these chipsets more efficient. One of the easiest things to do in any appliance, no matter how inefficient each individual piece of hardware is to just turn the things off that aren't in use. One of the very first studies that I did back when I was a youngster at LBNL was I worked with Alan Meyer, and what we did was took a heat camera and we took a picture of a set-top box when it was on, and then we turned it off and we took another picture. And the only thing that went off when we turned the set-top box off was the LED on the front. Everything else stayed on, stayed powered, and that thing just kept drawing power 24 hours a day. That type of waste is really kind of unacceptable. And I think that, at least here in this room, we can all agree that that's a very simple step that we should and can take, is to try to work with manufacturers to turn things off when they're not in use. Use the new intelligence in electronics to figure out when it is in use. If the television is off, the set-top box doesn't need to be on, and it can tell if the TV is on or off, and when it's off, it should go to sleep. That type of networking and communication between devices can make not only internally devices more efficient, but throughout the house as a network can make devices more efficient. And then the second piece is, of course, the individual hardware components. Displays are right now one of the biggest components that you can find in almost any device. When I say displays, a lot of people probably think, well, she's talking about computers. I'm not. Well, I am, but I'm talking about a lot of other things too. I mean, computers have a display, TV has a display, that clock on the wall behind us has a display, your iPhone has a display. Everything has some kind of a display, and some of these displays are more efficient than others. The most efficient ones you're almost always going to find are in the portable devices. Displays, audio, chipsets, every kind of component that you find in a portable device is going to be as efficient as possible in order to make that battery last as long as possible and to make that consumer electronic desirable for customers. So I think the next step then in hardware design is taking those portable chipsets and displays and power supplies and all of the other components that make a portable device efficient and moving those into devices that you plug into your home, whether it's a TV or a computer or a set-top box. And we've already made some progress here. I think a lot of us have moved to laptops. We started out with desktops that used 300, 400 watts just 10 and 20 years ago. And now I think a lot of us, mostly because we like the portability of a laptop, have moved to a laptop, and there's just no sense having a desktop anymore. But these guys use maybe, 20 watts, 25, 30 watts. And so that's the type of movement that's really going to make a difference, going from 300 watts to 30 watts or 20 watts, rather than saying, well, we can make a 10% efficiency gain here and there. It's really this big jumps that these innovative technologies can make when you go from something that someone didn't put a whole lot of thought into other than functionality. This TV works compared to we're going to really do everything we can to make this small and efficient. And so what I would recommend going forward is that we look at things by software and power management as one component of a device, and then secondly, as hardware components across many devices, whether it's a display that is a component in almost all devices, or a power supply, or a battery charger. And we've already made some progress in that front, right? We have now some standards for power supplies and battery chargers that are cross-cutting, are horizontal standards that reach all devices. And I think that we can go further with that idea and start reaching to displays and chipsets and other components of devices that would bring the energy efficiency of all devices.
Thanks, Karen. Why don't we move to Ian with ARM, who is, if you haven't heard of ARM, you should Google them, because I think I'm always amazed once I start learning a little bit more of how many devices we'll learn about and how far across the spectrum they are. So, Ian?
Yeah, actually, if you Google ARM, you're going to come up with adjustable rate mortgages and stuff like that. So I guess the first point is Karen's completely right, so I might as well just shut up. We started as 12 people in a barn in Cambridge, UK, about 23 years ago, and we purposefully compromised on performance for power. And in 1995, Nokia brought out the first GSM phone with a TI chip, and suddenly ARM came really by luck into the mobile phone space. And we've spent 23 years being incredibly economical on power, and other markets 20 years ago just didn't give a rip. And what's happened over time is that more and more markets have started to care about power. And I want to talk about sort of three areas. I want to talk about the infrastructure, because I think a lot of users think that stuff just comes to their phone and power and the internet is free, and actually the back end is going to be incredibly challenging. Second, I want to talk about the business area, and then thirdly, I want to talk about the consumer. So first thing, data point, the number 240 billion. It's the number of photos that were on Facebook as of January 1st this year. They're adding 500 million photos a month. All of those photos have to be kept on file for years by law. And so this is creating an incredible challenge where you store that information. And when you couple that with videos of dancing cats, which is another big topic, it's a challenge, right? People expect that user experience immediately across the infrastructure, and that is not free. And you see how people are building out data centers. The good news is the types of functionality you need in your server for that type of thing is very different from you know, if you look at the server infrastructure that's doing a lot of mathematic calculation in Sacramento, you don't need that kind of thing. You just need to basically serve up the infrastructure. And that's why the sort of activity that Facebook are doing with the Open Compute project is going to be absolutely vital. So we've really got to drive energy efficiency into the infrastructure and actually get people to care about it. Whether that stops dancing cat videos, don't know. But I think across all three areas, you've got to think about three themes, and one is power, one is security, and one is interoperability. When I come into the business, as Andrew talked about earlier, you know, the mobile platform has become your primary compute vehicle. There are people still going around with desktops. There are people going around with laptops, me included. I haven't jumped yet onto an ARM-based Windows RT laptop yet because I'm scared. But people are bringing phones into the business workplace. And so the security comes in because you've got to partition your personal world from your business world. Interoperability, right? You've got to have that interact with the rest of the subsystems. And it comes down to power and actually how do you provision and how do you encourage businesses to start replacing those laptops, which, to give a data point on from Karen, typically the power budget that we're given in a phone for our little bit of the processor is about 1.5 watts, okay? So, you know, when you think about people doing an all-day battery life, and yeah, there's some other stuff on the silicon chip itself. We're just a very small part of the technology. Our partners are the innovators and the clever people, so sorry, it's not me. But yeah, we're working in 1.5 watts, and that's a 2 gigahertz processor. It's pretty hardcore processing, okay, for 1.5 watts. And then you come to the consumer. And I could talk all day about the things you're going to see. You're going to see flexible screens. It's been confirmed by Samsung. You'll see a smartwatch next week. What you're going to see is your phone becomes your hub. And if you think about the phone knows it's you, where you are, you're going to see medical things. We're seeing deployments in places like Bangladesh where getting to the nearest hospital is a big deal. So people will start to deploy medical services on phones. And, you know, what does this mean? It's going to mean even more data across that infrastructure. It's going to mean an even more maniacal focus on the handset because we're going to have to work with that all-day battery life. Imagine if your phone goes down when you're having a heart attack, probably not a good thing, right? Really serious challenges in terms of security, interoperability, and on that last one, it's probably going to come down to indemnification as well. So what you'll see initially is wearables just for sort of like fitness and things like that. But you are going to increasingly see the phone be your portal that takes a lot more information back into the cloud. And that, again, if you think about security, interoperability, and power, you've got to make sure that people don't hack those devices. 3 years ago, an infusion pump was hacked, right? So a technology inside somebody's body that's diffusing liquids into the body was hacked because these things have a wireless interface coming out of the body. Same thing with defibrillators with heart rate monitors inside the body. Because they want to do some tuning when it's in the body, there has to be access via wireless. You can imagine that's a bad thing. So we've got to really, as an industry, look at how does technology get applied out for good, and how do we mitigate that by making sure the security holes and interoperability are fixed? Thank you.
So, am I going to do the presentation? Is this the presentation mode?
Yeah. I'm still stuck thinking about big cats and heart monitors, so sorry.
Dancing cats.
Dancing cats, sorry. Perfect.
They don't have to be big.
All right, next, Rich Fassler, and we'll put up, Rich has just a quick round of slides to show us.
All right, I'm the typical marketing guy. I can't do anything without a presentation, PowerPoint presentation. But I'll make it quick. Perfect. Okay, so power integrations. We actually focus on power conversion. And I'll just say one thing here that everything that was presented previously is right on the money, and there are a lot of things to take into account as far as the efficiency and operation. But every one of those things needs a power converter. Every one of those things plugs into the wall and then and takes 5 volts or 12 volts. So if you don't maximize the efficiency of the power conversion stage, you really don't maximize the total energy efficiency potential of the whole system. So, power integration, we're based in San Jose, California. Been around since, I believe, '88. As I said, we focus, we produce integrated circuits that form the heart of very efficient power supplies. And to bring up Alan Meyer's name again, back in the early 90s, we visited with Alan Meyer, not me personally, and learned about the energy vampires and the fact that things weren't turning off really when you push the button to turn them off. And based on that conversation, we developed our first EcoSmart chip, which actually reduced the power of a power supply when there's no load or at low loads. Up until this time, power supplies continued to burn a lot of energy, even when they weren't required to provide the total power. Our products can be found in about 70% of all the AC to DC power supplies and converters out there. So the chances are good that somewhere in your house or your office, the power conversion is being done with one of our chips. We shipped over a little over 1 billion ICs just last year, and that equates to 1 billion plus power supplies that go into consumer and business products. Okay, I've just got a few slides to go through here, but I thought I'd start off with what's going on with efficiency regulations for external power supplies. Because I attend a lot of these meetings. I attend efficiency meetings all over the world for the company. And the interesting thing here is that what happens in one part of the world finds its way into regulations in other parts of the world. For example, in March of 2012, the DOE proposed new efficiency standards for power supply, for external power supplies, and they were pretty tough. Based on what we have right now as a federal standard in the U.S., it's pretty wimpy compared to, number one, what's technically available or possible, and number two, what other countries have. And specifically in the European Union, they have a pretty reasonable mandatory external power supply efficiency requirement. It's basically based on Energy Star's program before they sunsetted that out. So very recently, the European Code of Conduct decided they wanted to revise their external power supply spec. So they took what the DOE had proposed and went kind of in between where they were right now and where the DOE was. So it was actually based on the DOE for Tier 1, and Tier 2, they'd be where the DOE was. Keep in mind, voluntary spec. European Commission also has a mandatory external power supply spec called part of the Eco-Design Directive. And they recently looked at revising the mandatory European external power supply spec, and they said, hey, this is kind of neat what the Code of Conduct did. Let's adopt pretty much all of that with some exceptions, and we'll just make it mandatory 1 year later. So by 2014, there'll be a voluntary external power supply spec that's much tighter than what we have in the States here. By 2015, there'll be a mandatory one that's much tighter. Meanwhile, we're all waiting to see what the DOE does. For all we know, the DOE could reduce their efficiency standards. Also, what we've seen is that there are efficiency programs, specifically Energy Star, that's identifying lower power modes. And so in products like computers, certainly set-top boxes, where we'd want that product to spend its time when no one's viewing any TV or your computer's in idle mode, we want to set some limits on the amount of power that can be consumed, which is basically just being wasted. And so now there are certain efficiency programs coming out that are putting some limits on the efficiency or the minimum efficiency of the power supply at that load, in this example, at 10%. We've seen that pop up in the Energy Star spec. We've seen that pop up also in the the code of conduct for external power supplies. So it's good news, bad news. Good news is, it really needs to be done. The bad news is not all power supplies are efficient at 10% load or 5% load. And so some of them have this efficiency droop once they get below 20%. So there's focus on that, and companies like ours are coming out with products that maintain that efficiency over the entire load. And also, there are programs that are introducing incentives for products that ship with higher efficiency. And the NRDC certainly worked hard with Energy Star to come up with a program for computers, for example, that ship with higher efficient power supplies to get a little incentive when they have to comply with the limits. Okay, so, and here we go. So what's going on in power supply land? Well, in USB charging, specifically in charging of our mobile devices, there's this thing called adaptive charging. Adaptive charging is kind of interesting. After a long day at the office and we're getting ready to go home, but we spend a lot of time playing Words with Friends on our iPhone, and the battery needs to be recharging. We don't want to stick around for an hour or 2 hours to charge that battery up. And so with adaptive charging, and we teamed up with Qualcomm on this with their Quick Charge 2, just recently announced a couple of weeks ago. There's a chip in the phone that says, hey, I need to charge up real fast. It talks to a chip in the power supply that says, oh, okay, no problem. I normally supply 5 volts at 1 amp, let's say, 5 volts at 1 amp, 5 watts to the phone when it's normally plugged in. But now, because you want to do a quick charge, I'll immediately change to 12 volts at 1 amp. Now I've got 12 watts to power your phone, and it reduces the amount of time that it takes to charge the phone. Not only that, it's more efficient because the power supply actually operates more efficient at 12 volts than it does at 5 volts. So we expect to see more and more of this. And the beauty of this, at least on I can only talk about the external power supply, the adapter side, it adds no cost because the additional small amount for that extra chip that goes into the power supply is offset by the amount of money that's saved on the secondary circuit, the feedback circuit in our power supply that it replaces. So it's really a win-win, and we expect to see more of this for mobile electronics. And then the nice news is, if you plug a phone into it that doesn't have this chip, this fast charge capability, it doesn't matter. It'll just stay right at 5 volts. At the same time, we're talking about USB charging. We've noticed now a lot of opportunities for us, for our chip, in wall outlets, USB wall outlets. They typically aren't called wall chargers because they offer AC as well as 1 or 2 USB ports. Each one of those USB ports has a power conversion chip in there. So here's an interesting thing. I mean, it's good news, bad news, right? It's a blessing and a curse. The blessing is you can be in the kitchen or the office or wherever, and you don't have your adapter, but you want to charge your phone, and you just do it without needing an adapter. The bad news is there is no standard, at least that I'm aware of, or specification or Energy Star program, or I don't know if Title 24 covers something like this, if it's hardwired. But once you plug this in to your house, it's converting power all the time. It's like leaving your charger in all the time. Now, if it's an external power supply, there are standards. There's a federal standard. Low power levels, in no load, it can't burn more than 300 milliwatts. But hey, if it's in one of these, it's not really an external power supply, right? It's an outlet. So the question is, what's going to happen here? Now, if you choose, and you can go to Home Depot, you can go buy these, they're not very expensive, and you take out the outlet in your wall and you put one of these in, now, that's Home Depot right now. It's on 24/7. And without any kind of standard or without any kind of efficiency spec on this, new buildings, new offices. How many of these are you going to put in your house? Like I say, it's brand new. Last year, we sold a few thousand units in products like this. This year, we'll sell a few million. So we think it's a trend that will continue to go without knowing what's going on. And finally, here's my last one. We talk about standby power. I'm here to tell you that in the power supply, in the power conversion stage, we have a number of solutions to reduce standby power in the power supply to, in some cases, to zero. And I'd like to tell you we're the only ones doing it, but there are other manufacturers who have their own solutions to do this. Now, in some cases, in a high power supply, you may need other circuits in there. For example, we have this product called Cap Zero, and it does away with the power that's wasted in bleed capacitors across the X cap. Now, all you need to know is that needs to be put in there, the X cap's in there, to reduce the noise, right? And there's a federal standard that power supply has to meet. And so with our product, you can save about 100 milliwatts, 50, 100 milliwatts. PFC circuits, another topic we could talk about forever. But in most PFC circuits, they require some kind of sense resistors. And so these sense resistors will burn energy whether there's any load on the power supply or not. So we have a chip that reduces, that actually does away with the power that's burned through those resistors. Other manufacturers have a different way of doing it. So the bottom line here is on the power conversion side, the solution's there to get to 0 watts or close enough to 0 watts. I think, do I have one more? Yeah. So the question, of course, is what does the end application need? What does a computer need when it's off? What does the television need when it's off for the remote control to stay active? There are solutions, some using our chip, and a major television manufacturer, that take it down to 0. You only have to get to 5 milliwatts to be able to round down to 0. That's the rule, right? So when we hear about programs and see regulations and talking about let's get down to 1 watt, can we get down to half a watt? We got to scratch our heads because the question is why does it have to be that high? So that's it from me on the power supplies. Thank you very much for listening to somebody talk about power supplies.
Thanks.
All right, great. Thank you. My pen.
Do we have any engineers in the audience? All right. Well, a few, I assume. Next with Voin is did you know that Rich is in a rock band? When we have drinks afterwards, you need to talk more with Rich. He's got a lot of great stories. So right as we came here, we just came from our assembly. Sue Cately, I think who's coming later, a great conversation about everybody was looking at their cell phones, and we were talking about how many devices are plugged into homes. And there was a debate about 10 devices. There was a discussion about maybe 20 and how it's growing. And we went back and forth, and really we came up with the fundamental conclusion of why don't devices that already display pictures and GPS and all your personal information, why isn't there a clear way to have the energy in all of these devices communicated in one central location? So I know somebody who has a solution to that. So we're going to have Voin next come up, talk a little bit about that. I also wanted to just acknowledge Commissioner Hochschild, who I know is in the back, so thanks for attending with us as well.
Okay, so my name is Voin Zivadinovic, and I'm happy to be at this panel. I'll take a little bit more of research angle, and what I'm fascinated about is the theory of energy proportional systems, which actually a couple of very smart Google people launched in 2007 related to the data servers. And You know, this is from our chairman of the advisory board, Professor Jan Raber from Berkeley, who is just comparing how we build systems today and effectively how we should be building those systems in the future. We design systems today for maximum performance at optimum design points. So optimum design point and maximum performance, where effectively the nature designs systems for efficient operation at many levels of performance and many levels of attention, and rarely operates at maximum performance. Now, we are approaching that angle. So the first users of the first iPad, when playing games, they felt the nature. It was on the left side because the system would run at the full power and it would burn their fingers. So in the next update, Apple already reduced that to a more reasonable power levels. I think that energy proportionality is something what we have to understand and we should follow in our practical lives. Very briefly about us, we are Irvine-based startup. Most of us held executive roles. Tom Colopy was at IBM and Qualcomm, was the founder of the company which brought Snapdragon to Qualcomm. I had the honor to work for Rockwell Semiconductor Systems in the 90s, then formed my own company, X's, in the late 90s. Sold that company to ARM and was ARM's vice president in a couple of roles for 6 years. What we bring to the market, and I will not bother you too much with that, but will gladly answer your questions, are effectively new technology for energy optimization of appliances. And we bring Energy Lab, which is a tool for energy optimization, a dedicated energy management kernel, and a unified hardware abstraction. And I will now touch to the last point, but from a different angle. Okay, so if you go and watch your favorite movie on Netflix, stream over the same speed connection, have the same TV connected in 1080p, you will be surprised that your box, which let us call it ITV, could be Roku similarly, is just using 2 watts, and that your PlayStation 3, which is a gaming device, is using 73 watts, which is a 36 times difference in power and, of course, energy consumption. Now, don't be surprised that 30% of the duty cycles of gaming consoles is actually watching TVs and similar. So just as a motivating example, I wanted to show you how we deal with energy today. So first, we start with smart people, from people who understand intellectual property, processor components, which then sell and present these ideas to semiconductor companies. Semiconductor companies sell those products to the board companies, they make applications, and then get connected to the utilities. There are 3 key phases. The number 1 phase is energy design. Number 2 is energy management. Energy design is how you pick your transistors, how you connect them, how you organize your system. Energy management is a software phase where you manipulate activities in the device to reach certain goals. And then energy deployment is everything from the network connectivity of these devices as well as the ways how they are deployed on the electrical grid. So all of these 3 generate certain energy consumption. Well, I'm trying to point that as it's today, we got a bit lost in translation, and that when you start, there's some parts which are not visible, but what we are saying here is that the people who are dealing with energy design, when they have to communicate with the energy management people and the energy deployment people, they don't talk the same energy language. The energy design people talk in terms of hardware languages, of hardware procedures. The people in energy management talk about software routines. And the people in deployment just get some numbers from data sheets. All of that really just increases the energy consumption because across those points here There's no consistent communication. There's not a single language which will help them cross that barrier. Let's go back to 1981. In 1981, we had a similar problem. It was identified by the US Department of Defense that the suppliers to the US Department of Defense would provide their ASICs, their circuit descriptions, in a variety of different formats. And the US Department of Defense struggled with that because they had to guarantee the consistency of the complete device. So what they suggested and pushed through is the procedures to document the behavior of ASICs so that supplier companies, when they ship their components, they speak the same language about functionality. This is very simply done by the base of formal text models that describe hardware function. And if you go to any computer science or electrical engineering school and you ask students about the VHDL, they will tell you, oh yes, I understand VHDL, I speak VHDL, and it's now standardized across the globe and helped bring forward the $10 billion EDA IP industry, which all these industry partners are using today, and effectively there will be no ARM, there will be no other big companies without that technology. So let's imagine we are now in 2014 and we are reading on a wiki page that there is a new energy-oriented hardware description which was originally developed at the behest of the California Energy Commission, and of course this is speculative, and Department of Energy, which documents energy profile of the plug load equipment. So basically we are saying the following: let's start top down, and for every device we connect to the grid or we manufacture, let's devise a method to formally describe the energy profile of that device and write text models that describe the energy behavior of that particular device. And hopefully one day we can read that this new form of formal description has helped us to develop energy design automation community, and as a previous business also mainly based in California. Now what are the benefits? The benefits of that is that for example, the regulators will be able to use a unified standard across all electronic devices, so that the tablet and the desktop and set-top box and a gaming console have the same framework how to describe its energy consumption. So one standard with just varieties of what we are particularly interested in. Let me remind you, it's energy proportionality. It's no big use of the gaming console if it could do gaming, but you're just watching HD movie. You have to measure the fact that you are interested in the HD movie. For the utilities companies, very simple and straightforward reporting about the energy profile of devices. The energy bill disaggregation doesn't have to become dark science or rocket science where we guess who is consuming what. We could just ask the device to report that own profile and update it during runtime. For the academia, obviously a new way to motivate young researchers to look at energy from a new angle, from an angle of a unified description for all devices. And last but not least, today's electronic industry, including Apple, including ARM, would not exist without automated methods, which came out of VHDL, which was formed by Department of Defense in 1981. And I can responsibly say, with quite some experience working for ARM, that functionality is a solved problem. Our senses have a limited bandwidth. We will not be able to invent anything more challenging for our senses than what we have today. We can talk about 3D, we can talk about real life and so on. Energy is a problem because we would like to have a phone which is charged as our calculator in months and effectively being completely independent ultimately of the energy resource. So I hope this is a little bit more challenging for discussion. I see already some hands, so that's a good sign. Yes, please, got that. Yeah, it's the question was about the load profile and the duty cycle, right? Was that more of the... So when highly respected companies like, say, Apple, for example, but there are other great companies, they develop their devices. They work in terms of activities. So your audio activities on the phone is 40 hours as you can see on the website. So audio on an iPhone 5 is 40 hours. They are very dedicated to optimally tune the hardware and software for that purpose. This is nothing else than describing that particular activity as well as its hardware and software activities related to that and expressing that in its power and energy consumption. So yes, you could ask the device, okay, in the last hour, how much energy did you use? You can ask the device for the last 6 months or for the last 12 months how much energy it used. The flexibility is very much given.
Great. Thanks, Boyne. We'll go
Yeah.
back to
Thank you.
Great. Thanks, Boyne, and thanks to all. So I'm just going to actually, of course, since I'm standing up here, a few basic questions, and then we'll move to any questions, other questions you guys have in the audience. Just to start as well, I mean, this is pretty heady stuff. I think the way we see it is solar panels, other things that are in front of consumers and relatively easy to comprehend and are extremely important in reaching our renewable and energy efficiency goals are great. People see them, they're on your roofs, they're important. A lot of these things can be just as important for reaching some of the goals as I started with on plug loads and really helping to meet our state goals. So as though I know that some of these are a little bit more advanced for many folks, one of the things that I think is really important is to try and understand some of these ideas, and in particular, the huge energy efficiency gains that we think can be made, in particular in this plug load area. So I challenge all of you for getting more engaged on this, because these ideas, although a little bit more advanced, are ones that I truly think over the long term can have huge state efficiency gains. So first question that I just wanted to throw out for everybody, and I just wanted to bring up the figure again, because I think it's useful. And as we talk about in the Title 20 standards process, we typically are looking at specific devices. You're looking at it at the very end product of a computer or a battery charger or these things. But what's really fascinating when you look at the computer or consumer electronics industry, it's complex. There's multiple processes, interrelations between different companies. So my first question, since many of you were right in the middle of industry, Ian and I were just talking this morning about having brought together the 1,000+ vendors that ARM works with, where in this process of the manufacturing of devices do you see some of the biggest energy efficiency gains happening now and maybe even in the future if you were to look out in the next 3, 4, 5 years? Like where do you guys see the industry headed? Where's the exciting areas for energy efficiency? Ian, can I hassle you to answer that easy question first?
Well, as you probably told earlier, I never use just a few words. I'd also caveat this with, if I was any better at betting on the future, my stock picks would have paid out. I didn't sell Broadcom at 278. Yeah, I mean, I think 3 years is kind of an interesting timeline. So I guess the first one is a term which I hate, which is the Internet of Things. And the reason why I hate it, well, that's a long list. We'll take the alcohol. But to me, Internet of Things is anything talking to anything. And that is so far away right now, it's just not even funny because of protocols are not set up, frameworks, et cetera, and there's just too many silos. But you are going to see in the next 3 or 4 years people using and connecting machines onto the network to save money. I think you are going to see smart cities. We've already seen great savings from companies being more efficient at how they do their trash collection because they're putting technology into rubbish bins. They're only getting emptied when they're full. Seen that in Pittsburgh. Car parking meters in San Francisco are saying when the space is open. It's ARM-based, by the way. And actually, the interesting piece of the parking meter thing is not necessarily the fact that it's showing you the parking meter or the fact you can use your phone, it's actually going to set up new business models, because actually in constrained systems, people will be able to say, oh, there's only a few places left in that parking lot, we're going to up our pricing, or we're going to offer some other things. So you're going to actually see businesses start to create new models as opposed to just efficiency. So I think you're going to see that, but it's going to be in very controlled environments. It's going to be a thing talking to one cloud service. It's not going to be this Internet of Things thing that Cisco says a bajillion things are talking to a bajillion things. No, okay? It's going to be in these sort of silos, but you're definitely going to see that. You know, we're spending so much time on electric vehicles. I really believe that is something that whose time has come. You know, we're very involved. I shared a story earlier that I went to Bosch 4 years ago and saw the lead architects of some of those new systems. I don't know how much you know about the value chain, but basically BMW and VW, they don't design the electronics themselves. They subcontract it out to Bosch and Continental and these people. And they had stickers on their wall saying, what have you done to reduce weight and what have you done to reduce power today? And so they have this maniacal focus on energy. And you see as people are driving out and you know, I'm just incredibly excited about the opportunities there. I think in 3 to 4 years, I think the other big area, to be honest, is going to be inside the data centers. And there's so much data. If you look at Facebook and if you look at Google, and if you look at the energy plant in the Three Gorges Dam in China, you know, I think it cost $22 billion to build. Phenomenal. We don't want any more of those on the planet. And so you look at what Facebook have done on PUE, the actual efficiency of their data centers, and like I said earlier, 240 billion photos that they have to store, streaming cat videos. There's actually a forcing function. And the good news is, and we talk about those guys as the server being the revenue-generating asset of the company. So not only is it just a good thing to do, it actually generates a benefit to the actual bottom line. And that's why you're going to see Facebook, Baidu, Tencent, the Chinese equivalents of Google and Facebook, doing it first, as opposed to Bank of America or Chevron, where that infrastructure supports the business. So those will be my three.
Rich. And don't talk about Internet of Things, just so you know. I'm just kidding.
Am I the only one who had to look up Internet of Things on Wikipedia? I mean, I've heard it. I had no idea what it is. But and just for the record, I happen to like those singing cat videos, so I hope they continue. So I'll just focus on the end applications that certainly that our products go into, and the things that we have in our homes and in our offices. And the thing that, in the area I think that there will be a huge a potential amount of energy saved, and the focus should be, is on, and it kind of is the Internet of Things, it's networked appliances. And when I'm talking about networked appliances, you know, it's, hey, we all are buying Internet TVs now. At the last CES show, a couple of manufacturers had network-connected refrigerators, our washing machines, our dryers, everything that we have, I think, ultimately is going to be connected on our Wi-Fi network. And you know, there are people looking at it, and I know the IEA is you know, working on it, and there's a workshop next month to figure out how we control the amount of energy that's wasted in those appliances. Because as it stands right now, you know, they can stay on all the time. I mean, you know, the Wi-Fi circuitry, you know, I don't know what it is, 5 watts, 10 watts, 15 watts, I don't know what it is. And so, you know, I predict that, you know, starting very, very shortly and moving on over the next few years, that there will be, you know, some studies that come out and hopefully some maximum power requirements or some auto power down. I mean, that seems to be pretty popular in standards and regulations nowadays. So that, you know, for God's sakes, between, you know, 1 a.m. and 5 a.m., I don't think anybody's going to go to the refrigerator. So let's turn the communication off, right? So, my 2 cents.
Karen, do you want to add anything?
Where are our biggest opportunities? Yeah. I think Rich is right that I think the networking and both between and inside devices, the software that decides what stays on and what goes off is one of the biggest opportunities that we have. It's also one of the most difficult challenges for anyone that's worked in that field. Whenever Rich talks, I can't help but think about all those hours I spent crawling around with my watt meter measuring the standby power of VCRs and DVD players and TVs. And me and a bunch of other research associates at LBL, Carrie Weber and Wolfgang Huber and Marla Sanchez, and we filled this database of appliances that didn't ever shut off. And I say I love to hear Rich talk now because I feel like, you know, we made a huge change happen. Not, you know, it wasn't just us. It was a huge group of people. It was international, but we were part of the change from these 2-pound, you know, blocks with fangs that stuck in the wall and sucked energy all the time. And now we've got these tiny little cubes, right, that you almost can't even feel. They're so tiny and they're so efficient. And that was just this incredible change that happened almost overnight. It seems like overnight to me, although I hate to think about how long ago that was. So I think that kind of thing can happen. It happened with power supplies, moving into hardware discussion. I think that there is a huge potential now for that to happen with displays, in particular, moving from, we've already gone from the big, ugly, heavy CRTs to LEDs and hopefully soon to OLEDs, which will have 90% savings even over the most efficient televisions and displays and other appliances today. So between the software networking efficiencies, which I think is very difficult, and then the hardware displays really, which is already in progress. It's one of those, how far do we push it? Sort of like lighting, we've gone from the incandescents to the fluorescents, which were better, and now we've got these LEDs. You know, how hard do we push those? Where do we rely on the market to say, look, we want these more efficient lights and we want more efficient displays, and where do we, as sort of a, you know, regulatory and volunteer standards, where do we put our efforts into trying to find ways to make things more efficient? I tend to think it's the software and the networking because it's more difficult and because consumers can't see it. They don't know if they're picking. They can see a TV, you know, and it says OLED. I know this is super efficient, but they can't pick up generally of an appliance or a refrigerator and know whether or not the networking on it is efficient and whether it's on all the time or not.
Boy, in your crystal ball.
In the crystal ball, I see energy as a content. I see energy as I'm plugging in my device on the IP network, and I'm plugging in my device in the energy network. The fact that it's today free or low cost, or it's not monitored, I cannot plug in my Ethernet cable and get service as I want. I don't think we will be able to do that in the future on the energy side. I think that we will plug in the wall and we'll represent ourselves as a device, so it's a Tesla car or a Volt car. It will be signaled to the system, and then we will be part of what we call today demand response, but it will evolve much, much further into energy as a content. And I think this will be bringing us complete energy awareness and effectively will allow us not to charge different ways, but to manage some emergency situations in a much better way. You know, currently, big heat wave, sun and offer is closed, we don't have power. Why to cut off all that power for emergency equipment, medical equipment, where we could selectively go and turn those charging their big batteries on a Tesla car instead of turning off the the medical equipment. So I see the future as energy as the content, and if we start pursuing that, I see voices from big organizations who are used to get that for free, unregulated, just plug it in, who will be louder and louder to try to stop that development, but I don't think it can be stopped.
Great. I'm going to ask one other question, and then we'll go to question and answers for anyone in the audience. And then hopefully I have a couple closing remarks from Andrew. This is a question that may not get an answer, but I'm going to raise it. I think one of the important things here in Sacramento that we talked with folks, and typically, as I mentioned at the beginning of looking at consumer electronics, we have the standard process moving forward, which I think has been very helpful. It's sort of a brave new world of looking at consumer electronics, again, where a computer is a tablet, is a smartphone, et cetera. That creates real challenges for looking at standards. Another way to look at this, which is what we are really hoping to dive into more, we had a lot of conversations around this today, I'm going to put people on the spot, is what other roles can the state have? We talked about other incentives. California has put out a lot of money for different programs, so asking for a handout for pushing more efficiency in consumer electronics may not be necessary. It may be helpful in different areas. There may be other opportunities for potentially giving a prize for the most efficient device. Where that might fit into this process is a new area. But really looking at new opportunities for really rewarding players with technology that they have or is right on the cusp of getting out to the market could really help move some areas forward. We talked about standby power a little bit today, but I just wanted to at least raise it and see if anybody had any specific ideas on that. I might even ask that from the audience as well with many of the folks here. But if you had any ideas for how to incent some of where that future crystal ball is that you see, what kind of incentives might get your company even to put out some of the efficient technologies you have quicker? An easy question. Anyone willing to take that one? Ian, come on. I'm going to taunt you. Internet of Things and big cats, fast cats.
What made you think I'd have an opinion on anything?
Because I know Voin will.
Yeah. I don't know. You asked me to answer it, and I'm trying to go without waffling. One of the problems we've got, I think, is people in technology are still fighting for putting up their own walls, and they want to protect their business. And so when we've come to Internet of Things, when we come to a way of how things are going to interact, it's really challenging. I mean, the phone people right now, the operators are really concerned about making more money, and they can't make money out of Apple and Android because the business model requires you to go and get, your app store, you take your money elsewhere. So the operators are wanting to put technology, other things out onto the network. That's one of the things that's driving machine to machine, is they actually think they can make more money there. But they want to do it in a way where they lock themselves in. And I think for us to be successful, and this is bigger than California, but we kind of have to have people like Sacramento just slapping these people around the head and actually, we have to get competitors to come together first. And if competitors don't come together and align, then none of this stuff's going to happen. And you're going to end up in this siloed world. And it's not much of a good answer, but I think, California has led in a number of initiatives and helping whacking people around, I think is a great start. Because competitors have to come together. And if not, then these things aren't going to interact. And if I take my medical example, we could look at that medical thing, but there's got to be a standard set of frameworks where that medical thing is authenticated. You can't have your personal data attacked. You've got to know who it is. You've got to be able to get that data to the right people. And we've got to do that in a better way than these sort of like click-through agreements that nobody actually reads. I mean, there's a number of things that we have to do. I guess I come back to, being that forcing function and just telling us as an industry that we're being stupid and sitting in our own silos.
So that fits perfectly of removing barriers also, not just the incentive side, which I think I focused on. Rich?
Just a quick question of clarification. Are you asking, what do we think that California or the California Energy Commission can do besides standards to help transform the market?
Yeah, and not even just Energy Commission. There's all types of state entities, whether
Oh,
it's
okay.
the legislature or our Public Utilities Commission. Yeah, exactly.
Yeah, I think, just being the CEC, I think the CEC does a very good job of pushing the industry to, with standards that are very possible to do. I don't think I've ever seen any standards come out of the CEC that couldn't be met already with the technology, with cost-effective technology available. And I think that alone, it's interesting because, and I mentioned this earlier, you know, what happens in Sacramento doesn't stay in Sacramento. We hear, you know, something will get proposed by the CEC, and then 2 weeks later, we'll get a request from, you know, an EPS manufacturer in China saying, hey, I need you to meet this spec. And it'll be what was discussed in the CEC meeting. So, and that same thing happens, for example, with the DOE, just proposing what the DOE did in March of 2012. We started having customers, power supply manufacturers, who, you know, build, you know, little EPSs for the major phone manufacturers, saying we're being asked to supply a power supply that meets Energy Star 6. Well, there wasn't any Energy Star 6 because the message got a little screwed up, but it was what the DOE was proposing in the NOPR that they still haven't finalized on. So, you know, my message there is, you know, what we've got now works pretty well. And, you know, hey, there could be technology fairs, there could be days in Sacramento where, you know, that were put together by the state, where companies like ours could have, you know, little show and tells and have, you know, real little, you know, touchy-feely stuff to certainly let legislators know, you know, what's available. Yeah. So.
Excellent. Anyone else want to add to that?
Sure,
Don't all
I'll
have
say something a little bit different. So I think it's good to incent the manufacturers and get them to work together. I also think it's important not to forget that the end product goes to a customer, and there's, you know, pushing is one thing, but what works even better is pulling. And if the customers demand that their devices are more efficient, then the producers will make it, and it will happen. And so then the question is, how do we make people pay attention and care? And I think that's something that happens over time. Anyone that follows my recent work, I've looked at time varying rates as one way to make people pay attention. If they have to think about, well, my rate changes, you know, once a day or twice a day, suddenly energy becomes a little bit more conscious to them. Or you brought up demand response. That's a dangerous topic. I could talk about that all day, but that's another good way for utilities to have the opportunity. And I'm not a fan of forcing customers onto rates. That's something that some folks are worried that these kinds of rates will be mandatory and that everybody has to do them. And honestly, if everybody did them, we'd have a bigger problem than we started with. Because the response from people who do pay attention and do want to do this, they find it's a game for them, they save money. I have participants in some of my studies that saved hundreds and hundreds of dollars over the course of a summer on a time-varying rate. When you give them the technology that they need to control their own response to the rate, not only do they have a tool that allows them to save money, but now you've given them power, and you've gotten their attention. And if they choose to be on a demand response rate, for example, the utility now has the opportunity to interact with that customer 10 times a year, or 12 times a year, or 15 times a year. They can now send that customer an email, or send them a text, or call them on the phone and say, look, you need to pay attention to your energy use today. And now that customer has really internalized, it's a very salient message to them, and they have to think about, what do I do right now that can save energy? That forces them to become educated about what saving energy even means. Most people don't even really think about energy. You know, you turn on the light and it comes on. You know, I turn on my TV because I enjoy watching whatever it is that people watch. Cats, I don't know. But if you make them think about it once in a while, then they educate themselves. In the studies that I've done, the customers that were given education on these rates or weren't given education had the same response, and it was so much better than the customers that weren't on the rates. We got a 5% overall efficiency gain from a time of use rate with these occasional emails and text messages, and that was not, there was no measures involved, and 5% efficiency is good. Peak shaving was 30% on weekdays, and that was just a normal weekday with no events. During an event, we got a 60% load drop. And these customers loved this program. On average, we had 42% of the customers on that rate saved more than $100 over the course of the summer, compared to the folks on the tiered rate who on the same program in every other way, only 20% of them saved over $100. So we got greater bill savings, greater energy savings, peak savings, and event savings on a rate. And it was a completely voluntary program, and the customers really enjoyed being on it. 94% of them signed up again for the second year. And so for me, I think, yes, we should work with vendors and find the ones that are the most efficient and can help us put out products and sell products, but we also need to find those customers that are going to buy those products, right? And that care enough to buy those products, and find ways to educate them about and incent them to care about this topic.
Go to Voin. And just a quick plug, we are actually also hosting a conference directly on this with the governor's office September 10th down in Santa Clara on smart grid issues. So all of these will be hopefully discussed in a lot more detail. Voin?
Honestly, I'm fascinated with the story of catalytic converters. If you read that story, how California became the place to launch that incredible technology. I'm old enough to have suffered from the cars in US and in Europe and so on, and take a look how we live, what the luxury of air we have at the moment. And it was about this invention. It was about the idea, which came out of a guy who actually came out of France, came to California, launched that idea, and it was about the relentless leadership of California to push the ideas forward. Like Steve Jobs did the iPhone and iPad, like this person did the catalytic converters, like thousands of other ideas have been born here. And effectively, a lot of them have been actually dismissed, but have been proven whether they work or not. And I would expect that California has the power and the ability to explore these venues, because some of these ideas could be very, very beneficial. And whether this is demand response or common energy profile, I think that's what I would expect from not only the California Energy Commission, but in general from the infrastructure in California, not to leave ideas on the table, check them, prove them. If they're good, take them. If they're not, obviously everybody on the planet will copy them anyhow, right? So whether they're good or not. So thank you.
Ending on a big idea. Thanks, Voin. That's good. Any questions in the audience? Start here. So if we have a microphone, so Kibby will come over and give it to you. If you could just announce who you are and where you're from, and then question would be great.
Can you hear me? Yes. So thank you for the panel. I think it was fascinating discussion and information. So I'm Pierre Delfort from NRDC. I have two questions, a quick one for Voin, and then another one for the whole panel. So Voin, I was curious to know how much your technology that you've presented on a typical consumer electronics device, could you give us an idea of how much you'd be able to save, how much energy you'd be able to save? And then if I can just quickly queue up my second question. We hear from the consumer electronics and IT industry that the efficiency of electronics is increasing very fast. Computations per watt are doubling every 18 months or so. At the same time, computers and other electronic devices are becoming more powerful, have more features, TV size is increasing, there's more of them, people watch them longer. And the result is that the electronics are still the fastest growing source of energy use in homes today. So my question to the panel is, can we break this cycle? and reduce the aggregate energy use of consumer electronics in homes and offices? Could you comment on the cost? Not expecting a precise cost, of course, but how significant is it and for doing this? Thank you.
I mean, so far, as I said, we are a startup. A couple of Qualcomm, ARM, IBM people who came together on a system on chip developed by Mindspeed Technologies out of Newport Beach. That's a spin-out from Conexon and Rockwell, which is now in 5th generation in Japan for the equivalent AT&T. They have NTT. We have been able to cut it 60% down from a steady cost, from the idle power consumption, and around 40% for the active mode. Why? Because we put the device in fast sleep and fast wake up. So we say normal devices sleep between cups of coffee or breaks. We sleep between keystrokes, because between keystrokes, nothing is changing. So that would be the best I can tell at the moment.
Does anybody else want to tackle Pierre's easy second question?
Second question.
Anyone? Karen?
I'll try a little bit. The second question was, can you remind me? How to break the cycle, right. So one way is to get the consumers directly, right? I mean, I think all the things that we've talked about today, I don't know that we're going to break the cycle entirely. I mean, obviously things progress and people want more and faster computers. I think a good example is televisions. On page 6 of the report, if you happen to have it in front of you, televisions are the biggest plug load in U.S. homes, at least consumer electronics. And while the overall energy use of a single of the displays themselves are becoming much more efficient, right, over time. We now have LCDs, which are much more efficient than the CRTs. And the number of TVs being sold is relatively constant, but the energy use is going up very quickly. And does anybody want to guess why that is? If they're more efficient and we're not selling more of them, why are they using so much energy? Because they're so much bigger, right? I mean, they're huge now compared to what we had 20 years ago. And so are we going to stop that? Well, eventually, sure. I mean, at some point, the TV's not going to fit through the door. But yeah, they're going to keep getting bigger. People like bigger and bigger TVs. And so then we need some kind of technology like an OLED that is really going to make a big difference in the energy use. But when it comes to, is a faster processor going to use more and more energy? I mean, I think these guys on my left can probably answer that better than I can. I think they're doing a pretty good job so far keeping it down.
Are you saying I can't go to Fry's every Friday and go buy something new that I don't need? Is that what you're saying, that I should stop doing? I think the answer is to keep on, to try to do what we're doing, but faster. And that is, as Karen said, identify the big energy hogs. I mean, I remember a few years ago, we had to attack television consumption. Right, the new flat panel TVs everybody was buying, and I think the NRDC NOAA put out a short paper on that, and then it was set-top boxes, and we're not done yet on set-top boxes, but certainly there are a lot of eyes, looking at set-top boxes to let those things go to sleep, and okay, so set-top boxes not done yet, but working on it. Network appliances. I just saw the NRDC, what was it, about a month or so ago, a paper that came out. And I think that's the way we do it. Because history has shown that engineers have found a way to get the function that we want with less energy over time. Right? The first flat panel TVs that came out were great, but they're energy hogs. They were using 400, 500 watts. And now you can go and buy not a top of the line, you can just go buy a pretty inexpensive, 50-inch TV that uses less than 100 watts. And there are better. So my answer would be that we just need to move a little faster on, number one, identifying the next product on the, on the list, and go after it, somehow transform the market through regulations or through technology to combat it. Because we're not going to stop buying this stuff, and we're going to buy more of it. And the next new, tablet that comes out that allows me to do something else, me and a million other people are going to go buy that one. So.
Yeah, I think unfortunately I'm going to disagree, and I think it's going to get worse nearer term for the reasons that Karen said. And to be honest, I think it's because the people are going to keep adding stuff. I mean, if you look at TVs, the next set, there's already some TVs at the high end where they actually have facial recognition. There are TVs coming where actually, if they detect a child walking across, they'll pause the program if they realize it's not appropriate. Now, do you need that? Don't know. But people they need new things to sell and differentiate the Samsung product from the Sony product, whether we need it or not. And I think, unfortunately, at the moment, it's not high enough an agenda item that power dissipation doesn't sell TVs, new wacky functions, your cat capture video, whatever, we're going to carry on that theme. I mean, seriously, the facial recognition thing, that is pretty high performance processing. I could get all nerdy on the number of gigahertz. And you could argue it's a great thing that somebody walks in front of the screen or actually I've seen where if you look away from the screen, the picture stops and drops down into power. You could talk about that being a cool thing. At the end of the day, it's going to burn a lot of power and a lot of performance. And so I actually think it's going to get worse before it gets better.
I wanted to just chime in on this question, build on something that Karen said about sort of getting the consumer engaged. And I think we run a regulatory proceeding that's not the most penetrable thing in the world for your average person, but industry representatives are coming. They participate. Advocates, NRDC, others. The utilities. There are a lot of highly informed stakeholders participating in the conversation, and that's great. In the last Title 24, the building efficiency standards, we really had an amazing process, I thought, where we basically ended up with a consensus standard, and that was based on a lot of heavy lifting, hard work, lots of communication, hammering out the tough issues. Figuring out where industry was going to have real palpable problems, practical problems, proposing solutions, working through that. At the end of the day, we adopted some fairly aggressive standards that were consensus-based. We had the building industry and the trades supporting our highly energy efficient building efficiency standards that are now, in January 1st of next year, going to come into effect. So I'd like to be able to replicate that in Title 24, where we really have, a sort of everybody comes with their, best participation, everybody in good faith, good conversation, and NDAs where they're needed, absolutely acceptable. But really would invite all the stakeholders, all the parts of industry, the progressive parts, and everybody to bring their best information and participate in the conversation. And among those stakeholders, there really does need to be consumers. We know in California that consumers support energy efficiency. In concept, they get it. It makes all the sense in the world. You can, doing energy efficiency has a long-term impact if you're going to have a device that you have to plug in every day. People intuitively know that the little tiny transformers and the USB chargers that they're carrying around now are inherently better than the hunk of iron that they used to carry around a few years ago. They may not put it in energy efficiency terms, but they absolutely understand that. So I think that we'll see ex post, when we go through this transformation, we will actually see consumers understanding that it has been a good thing. And so our problematic is to chart the path from here to there. Whether that's in a regulatory proceeding at the CEC or elsewhere, or whether that's just in the marketplace, I think remains to be seen. But I want to just, getting the consumer voice. We're talking about consumer electronics. It's a whole package of qualities and features that they have. Well, energy is one of those. It may not be the highest priority, but it certainly is one of those. And lightness and portability and all those kinds of things are hand in hand with energy in a lot of important ways. So, I feel like the communication with the customer at the market level out there in the world through advertising and whatever, absolutely, that needs to happen better and more effectively and incorporate more energy messaging. But also in the proceedings that I run and that will continue at the Energy Commission, I think having consumer representatives like the Consumer Federation of America and others much more actively engaged in that will bring that common sense consumer perspective to the energy discussion, which we know has traction. And so right now it's sort of, it's more sort of special interests that have a very directed interest and they're highly professionalized. And expanding the conversation to include more of a consumer orientation, I think, would really help the process and help move it along in the right directions. So I wanted to kind of build on what Karen said to make that point.
All right, sorry, let's go through questions. I'll push our folks along here quicker. Kibi, has got a microphone.
My name is Michal Haramati, and I'm an associate at Opinion Dynamics. And I guess my question is probably for Karen and to the rest of the panel too, to the extent that you have ideas. And it really is, what additional value is going to be provided by the ability to control plug load and turn off devices when they're not in use to the customer that's going to lead to that pull. So with LEDs, with this transition from incandescents and CFLs to LEDs, there was this new functionality and these new things that were largely non-energy benefits that customers couldn't do before. They got lights in different colors, and you can put lights in a whole display area, and you can turn them on and off at different times. You can program them. That's something that we couldn't do before, right? And that's something that customers say, well, we want LEDs for this increased functionality. So what is it that's going to lead to that customer pull on the energy side?
That's the question, isn't it? Yeah. So unfortunately, we always start with money, because when you ask customers, why did you sign up for this energy efficiency program, or why did you sign up for this, they always say, I wanted to save money. That's one way, and there are lots of other ways. There are normative messages. Everybody else has a tiny little light little set-top box. Why do you have that big heavy honking thing that's heating up your cabinet? There are green messages, right? So then it becomes a marketing issue. And how do you get customers to care about anything? How do you get customers to buy anything that they don't need and isn't going to benefit them? Well, if I'm a good marketer, I can do that. So if I'm a good marketer, I can certainly convince them to do something that actually is going to benefit them and ultimately, their kids or the rest of society. I think it's just a matter of how good are you at convincing people of doing things or money.
Any other thoughts? Actually, maybe we'll just go to one and see if we have another question. But
Tony, can I?
Oh, sorry, one. Okay.
I just would like
Just a
to
brief.
mention the example of the catalytic converters, right? People sitting in the car, they don't see a difference. People who live outside in the country also didn't see a difference, and we have that mandatory today, right? Because we as a society benefited enormously. Our kids are healthier, we live a better lifestyle. Similarly, demand response would help us to reduce the number of new coal-fired or, God forbid, nuclear plants we have to build in order to supply our network with energy, So no direct lights or nice benefits, but long-term, wisdom speaks for certain solutions. And I think it will be only a matter of time, and we'll be regulating energy differently.
Of course, the nuclear and coal plants will be outside of California. Just kidding. It's Julie right here. And we're just getting around the end of our time, so we'll probably have this as our last question and then maybe hand off to Andrew to close us out, and then drinks are in the back.
Yes. First, I'd like to thank all the panelists for the great discussion. I learned so much from the conversation. My name is G.P. Lee. I'm from UC Irvine, representing CalPlug. Currently, it's funded by, actually, it's repair money and through CEC. I learned the lesson this afternoon. So my question is, currently what we have learned from the consumer electronics, we see a convergence is happening in the markets. So consumer electronics used at home for home entertainment. And everyone now is talking about also using the same device for home energy management. And when we talk to the medical doctors and for the upcoming e-medical records, we also see the trend towards home medical care using the same set of electronics. And that is the answer to you is now there is a potential to offer new functionality out of the same set of device, consumer electronics, for a variety of functions to address different users' needs. I think that's an opportunity for us. But at the same time, I'm facing one challenging question is when you're dealing with a different sector of business, home energy management, entertainment, medical care, they are at different sector of business. So there is a need, I think it's from our point of view as a stakeholder, as well as consumers, to recognize how do we really bring different sector of business together to look for holistic solutions so that we can have a cross-border energy savings. I think that is something maybe we can drive at as a long-term goal. Thank you.
Great. Well, with that, I'll hand off to Andrew. This will be on our website, just as my final plug for greentechleadership.org. We're hoping to have these type of events every couple months. I think as we saw today, there's a lot more opportunities. The next one should be around vampire loads, which is always fun in October. So thanks, and with that, thanks to everyone, and I'm going to hand off to Andrew McAllister.
Well, thanks very much, Tony. I don't have a lot to add to the discussion at this point, and I think we're all ready for a drink. Thank you, Professor Lee, for that point, because that was an excellent point. And you know, Voyen has brought up demand response a couple of times, and I think you know, in the best of all worlds, the single investment that we might make in a certain technology or a certain standard. As communications technology gets cheaper and more prevalent, and we unlock sort of innovation, figures out what the best and highest uses or the possible uses of those communications actually are. You know, having smart devices, having low power devices, having devices that can communicate in both directions is it's a kind of not a large leap to see that as potential demand response resources across the state. And so it does enable demand side, small scale supply side incorporation into our electric grid, which is increasingly an important issue for California going forward. Energy storage devices, electric vehicles, all of these devices, you know, optimally would be communicating you know, under one conductor as an orchestra, you know, and hopefully not, you know, sort of like Rage in the Machine or a cacophony, or, you know, hopefully it makes sweet music together, and that's obviously the goal. So there are a lot of reasons to think that convergence is possible, but you know, that's not the easiest thing to do in a fairly rigorous regulatory setting. The marketplace really has to play a leadership role in that, and so I think the Commission, we can try to help to set that tone, set some expectations, encourage, facilitate, that kind of thing, and obviously do our role as the regulatory body in the ways that we know, but also help the marketplace figure out what to do. I mean, and actually I would hold up, there are a few examples that have been given through the day, but you know, the sort of big gnarly goal that we might as a state set out for, you know, a metric or a goal that we might say, hey, wouldn't it be great if we could, you know, get to the moon, and then give it some time, encourage a facilitated discussion, and try to get there. You know, I think Department of Energy, just to hold them up a little bit as an example on the Sunshot Initiative, they've done some really nice things in the solar arena with not that many resources, not that much money, not that much funding, but they've spread it in ways that are very savvy and chosen some good partners. And so they've managed to set a goal for $1 a watt installed solar. And I think they're making good progress on that. There are a lot of people working on the hardware, working on the R&D, working on the soft costs, which is extremely important for getting the cost down. And I think we ought to be thinking about goals that we might establish on the energy efficiency side, consumer electronics or in other sectors, to really bite off a big bite, but then work together to try to achieve it. And I think this forum right here has helped us bring some new ideas forward that we might begin those discussions. really not focused on a particular proceeding or a particular device category, but really on these larger issues to try to continue that tradition of California leadership. I'm very excited to be here. I'm very optimistic about how much there's a lot of great innovation going on, and there's just no way that a lot of good is not going to come out of that. So I'm extremely dedicated to this, obviously, as all of you are, but also optimistic that we're going to have some really good results. And just, you've heard a lot of the innovation. You've heard a number of companies here today and research that's highlighting these great successes that have happened, that are on the cusp, and that, in the next few years are coming down the pike. So I would like to, again, thank the Green Tech Leadership Group for putting this together, and Energy Foundation for sponsoring, and I'm happy to be here, and let's all retire to the bar, I guess. Thanks very much.